So now we'll move on to telling if a function is increasing or decreasing. As we know, a function's derivative measures its rate of change. So if the graph of the derivative lies above the x-axis and it's positive, that means the rate of change will always be positive, so it will always be increasing. And if it's below the x-axis and it's negative, then that means it will be always decreasing. And if a function is increasing, if its derivative is greater than 0, and if it is less than 0, it is decreasing. So functions can be increasing or decreasing at different times. So say for, we could find the set of values for which x is increasing. So if f of x is x squared minus 8x plus 2, we'd do f dash of x. This is another notation. This means dy dx as well, 2x minus 8. And now we'd see when this is greater than 0, so it's when x is greater than 4. Now we could also do a similar thing for when it's decreasing. So when it's less than 0, so 2x is less than, well, it'll be the same thing, less than 4, but for a different one, you'd be able to do that. And you may have to do a quadratic inequality for this as well. And you also may have to do chain rule, remember that. And you also may be asked to find out whether a function is increasing or decreasing. For example, something like this. And what I would do is I would just, and it's saying for x is greater or equal to 0, it's specified a domain. What I would do is I would simply just figure out when it's increasing, when it's decreasing, and from there I should be able to figure out whether it's going to be increasing or decreasing, and I can give a reason. So when we do this rearrangement, now I can multiply by that x plus 2 bracket squared, because squares are always positive. And then that will cancel, so and so 5 over 2 will be greater than x plus 2, so x will be less than 1/2. So when x is less than a half, it'll be an increasing function, but when it's greater than a half, it'll be a decreasing function. So it's actually neither increasing nor decreasing. They may tell you whether it's decreasing, increasing, or neither, and you have to prove that. But I would say that this is all you need to know about that, really. And just remember, when you do inequalities, you can only multiply and divide by positive numbers without having to change the sign. And when you've got variables involved, only ever multiply out a denominator if it's got if it's a perfect square or an even power, any even power. And if you remember in the rational inequalities video, you find the critical points where it when it might cross 0, and that can help in this situation. So it's really and additionally, for say, if you wanted to prove that something with an f dash of x, or dy dx is a quadratic, you could also prove its increasing by finding the min and max, and depending on whether it's U-shaped or N-shaped, that could be a reason. You could also do discriminant to show it never crosses, and then you explain by saying whether it's U-shaped or N-shaped that it will be increasing or decreasing. Because if it's U-shaped and doesn't cross x-axis, that'll be always increasing. But if it's N-shaped and doesn't cross the y-axis, it's always decreasing. And this can be used to model things like the profit functions and whatever like that. But I think that's all I have on that for now.